Last week I solved problem 10, which is this one here, to illustrate how to solve a linear programming problem. Well, I just want to add to this problem what is said at the end of section 2, which refers to the standard form and also the slack variables, and specifically the slack variables. Well, if you recall from the solution of the problem, it turns out that A is equal to 12 over 7 and B is equal to 15 over 7. Now, if we replace those two values, the solution to the problem, back into the constraints, then we have 12 over 7, first constraint, 12 over 7 plus 2 times 15 over 7 less equal to 6. Well, this is 12 over 7 plus 30 over 7, 2 times 15. So notice that this is 42 over 7, okay, which is 6. And that is equal to 6, if you notice, which is the right-hand side of the constraint. So in the standard form, this constraint is written as A plus 2B plus a slack variable less equal to 6. This is a slack variable. In other words, this is a number that we need to add to the left-hand side to make it equal. Sorry, this is equal. To make it equal to the right-hand side. In this case, you need to add that number because the left-hand side is always equal or less than the right-hand side. Well, in this case, 6 is equal to 6. In other words, if we write this problem as a slack variable, including a slack variable, we will have 6 plus S1 equals to 6. Well, that means that the slack variable is simply 0. So it's a 0 slack. Now, on the other hand, in the second constraint, 5A plus 3B, is that equal to 15 or less than 15? Well, 5 times A again is 12 over 7, plus 3 times B, which is 15 over 7. Okay, this is my second constraint. Well, including the slack variable, this will be equal to 60 over 7 plus 45 over 7 plus my second variable, my second slack variable, equals 15. These two are equal to 105 divided by 7 plus S2 equals 15. 105 divided by 7 is equal to 15 plus S2 equals 15. S2 equals 0. 15 minus 15. So the second constraint also yields a 0 slack. And the reason is because the solution is found at the intersection of these two constraints. So these two constraints are said to be binding, and therefore the two constraints are binding. In other words, they define the solution of the problem, and therefore that's the reason why they have a slack of 0. However, if you follow the slides on chapter 7, in slide number 8, it shows the problem maximize 5x1 plus 7x2 subject to x1 less equal to 6, 2x1 plus 3x2 less equal to 19, and then x1 plus x2 is equal to 8. And the traditional, not traditional, but the non-negativity constraint that has to be in all these problems. Well, the solution to this, which is found in the same slides, on the slides describe how to find the solution. The solution is x1 equals 5, and this is found in slide number 15. Number 15. And this is number 8. slide number 8. And the solution is x1 equals 5 and x2 is equal to 3. That's the solution to the problem. Now, if we substitute these numbers into, let's say, this third constraint here, that's my third constraint. Well, it'll be easy. 5 plus 3 is equal to 8, right? And is exactly equal to 8, the right-hand side. So the slack number 3 is equal to 0. Of course, more formally, you can write it as 5 plus 3 plus slack 3 equals 8. But this is 8 too. So the slack is equal to 0. In other words, it defines the solution of the problem. And that is, you can see that in the graph shown also on your textbook. Now, in relation to constraint number 2 here, 2 times x1, which is 5, plus 3 times x2, which is 3, plus the slack number 2, is that equal to 19? Well, this is 10 plus 9 plus s2 equals 19, and indeed is equal 19. This is 19. So therefore, again, I have a slack equals 19. I'm sorry, equals 0, because the two, this 19 and 19, left-hand side and right-hand side. So there is nothing wasted in the two constraints, so to speak. And the solutions of the two constraints are binding. However, the first constraint, notice the first constraint is x1 is equal to 6, this one here. And obviously, if you see the solution is x1 equals 5, so the solution is 5 plus slack 1 equals 6. So therefore, the slack 1 is 6 minus 5, and that is equal to 1. Why is that this constraint has a slack? Well, the reason is because this is a non-binding constraint. This constraint, if you follow the slides on the chapter 7, helps define the feasible region or the feasible area. However, this constraint does not define the optimal solution. And in fact, what you get is a line like this, and you get a line like that, and there are two lines that define the solution. And if you notice, this is constraint number 2 and 3. If you go back to the solution in the picture shown in your slides, but this is a constraint that x1 is equal to 6. Right here, this is number 6. This is x1 and this is x2. And clearly, you can see this point is not on this line. So therefore, this line, it helps define the feasible region, which is something like this, but it is not, the optimal solution is not on that line. So that line has a slack. What is a slack? Well, this solution here is right at x1 equals 5, and there is a 6 here in excess of 5. And of course, the excess is the slack variable that is needed for the left-hand side equals to the right-hand side. And that is the case of slacks. Okay. I will post another video soon showing minimization problem and also how to solve these problems using Excel.